In this video, I'm going to show you how to do integration by parts. And essentially what integration by parts is a method that takes a complex integral and makes integrating it very simple. So how does one go about using integration by parts? Well, let's say we have some function and we want to integrate it, and it's f of x times g prime of x. We say that this is equal to f of x times g of x minus the integral of g of x times f prime of x. Then what some people like to do is they like to say that f of x is equal to u and g of x is equal to v. And the differentials of these then are f prime of x is equal to du and g prime of x is equal to dv. So what we can then do is continue to say that the integral of u dv is equal to u v minus the integral of v du. The reason we represent them using v and u is so we can make a table that makes integration by parts very simple. And the table looks like this. U is equal to f of x, and the derivative of that is du is equal to f prime of x dx. And then we have v, or dv, is equal to g of x, g prime of x dx, and then we have v is equal to g of x. And this allows us to represent this first part of the equation to be multiplied by this, and then the second part, or the integration part, to be represented by that, or v times du. Let's do our first example problem of integration by parts. Let's have the integral of x squared ln of x, and in order to make our life easier, and for this example, we should have ln of x equal to u. So we have u is equal to ln of x, and the derivative of u is then 1 over x. And if you don't know that, then you should probably learn it. It's very important in calculus, and it'll help you almost everywhere. Then, secondly, we need to have dv. dv, we're going to have equal to x squared dx. And that is going to make our life very easy. So dv is equal to x squared dx. And when we integrate both sides, we then get v is equal to x cubed over 3. So when we use integration by parts, we want to have u times v for the first part of the equation. So we have u, which is ln of x times v, which is x cubed over 3, minus this v times du, which is then the integral, or the integral of v times du, which is x cubed over 3 times 1 over x dx. And then we can cancel the x's, so we get x squared, and pull out a 1/3. We can pull out a 1/3. Now we can continue to solve this integration process by integrating what's left and by reducing everything else. And so in the beginning we have x cubed over 3 times ln of x minus a 1/3, which is this 1/3 out front. And now the integration of this x squared over 3, or x squared, is going to be x cubed over 3. If this is general integration, you should be able to do that. And now that all the integration symbols are gone, we need to add a constant on since there were no bounds on the integration. And we can continue to simplify this by either pulling out an x cubed over 3 or an x cubed over 9. I'm going to pull out an x cubed over 3, and that gives us x cubed over 3 times ln of x minus a 1/3 plus c. And that's the integration, or that's the answer to the integral of x squared over ln of x dx using the integration by parts. Let's do our second example of integration by parts, and we will have it equal to t squared e to the t dt. We can now start making our table, and I'm going to have it u be equal to this t squared right there. So it's t squared, and the derivative of both sides is equal to 2t And then the second part of the integral, e to the t dt, is going to be dv. So dv is equal to e to the t dv. And if we integrate both sides, we then get v is equal to e to the t. And if you don't know that, that's a basic integral that you should know from calc. And it's very simple, so I suggest you learn it. Along with ln of x, the derivative of that. So then we can set this equal to, and we know that it's u times v, which is going to be t squared e to the t, and now minus the integral of v du, so minus the integral of e to the t 2t dt. And we can then continue to solve this, so we have t squared e to the t minus, I'm going to pull the 2 outside of the integral, and so now we have the integral of e to the t dt. You may be wondering how we can integrate e to the t times t, but it's just as simple as what we've been doing, using integration by parts. So we have t is equal to u is equal to t, therefore du is equal to dt. And then we just set the rest of the integral e to the t times dt equal to dv. And I just noticed that this is dt, not dv. So dv is equal to e to the t dt. And therefore, integrate both sides, we get v is equal to e to the t. And so what we need to do then is to continue our process of the integration. And we get t squared e to the t minus 2 parentheses, because it's the integration by parts of everything on the inside. So we have u times v, which is t to the e to the t, t times e to the t, minus the integral of v du. So we have e to the t dt. And we continue, and we get t squared e to the t minus 2t e to the t plus 2e to the t, because the integral of e to the t is e to the t. And now that all the integral signs are gone, we need to have a plus a constant, which gives us, if we want to simplify it, that's solved, but we can simplify it to equal e to the t times the quantity t squared minus 2t plus 2 plus a constant. And that, my friends, is how to do integration by parts of t squared times e to the t dt. And thanks so much for watching. I hope to help. Like and subscribe and see what else I have.